Okay, so we're looking at extrema. So this is how I want to pose this to you. So the way extrema work, I'm just going to draw a graph in general. I'm going to create that. Let's do this, this, and this. So this will help us with describing a couple of things. All right. So I'm going to put a point there. I'm going to put it and make it black. And you should draw this curve as well. So this will help us with the definitions. All right. And so this graph, it's not continuous. It doesn't keep going at its ends. It actually stops very firmly. So let's identify a couple things. So they talk about local maxes, local max, and a local max is, it's a peak. It's at the top of a curve, right? So this right here, this is a local max. This point at the top is a local maximum. All right. Now, absolute maximums, these are our highest points. So between this point and this point, this one looks higher, so it's the absolute maximum. That means this point on top of this peak over here is a local maximum. It's a local maximum. Now, how do I identify the local minimums and distinguish between the local minimums and those absolute minimums? So a local minimum, it's not the lowest point, but it does form a little peak there. So there's a local minimum right there. It forms a little valley actually. So peaks for maximums, valleys for minimums. However, our local absolute minimum, it is literally the lowest point. It is literally the lowest point. So keeping that in mind, we've identified a couple of things, and maybe you want to label them. I've highlighted them just to create shortcuts. But if we look at P right here, P, and perhaps I should do a different color, P is an absolute maximum. There is no absolute minimum, and in fact there is no minimums at all. So when we're labeling these things, we want to write that down. Okay, so we have an absolute maximum here. All right, look at the next one, the next graph. P at this point, my bad, there, scroll down here, but P here is a minimum, and it's an absolute. It's the lowest point. So we would label that absolute minimum. Now P in our last graph, that's a unique type of, that's a unique point. It's a unique point because it's constant. It's constant. It's actually vertical here. So you would describe this as a point. It's a point of inflection. And you might see this written sometimes, but it simply means point of inflection. All right. So let's identify maximum and minimum points, and what we'll do for max and mins, I'm going to highlight all of my maximums orange. So here's a maximum. It's a local maximum. I would not count these endpoints as maximums because this looks like it's continuous, like it's continuously going up. So you have to be careful and cautious. If I don't see a point ending that segment, then it is continuous. So there's only one maximum there. There's only one maximum. Here I have an absolute maximum. So we have a local maximum and an absolute maximum. So let's look at for our minimums. And I'm going to make these brown. In fact, I'll put a little box. So here we have a minimum, and here we have a minimum. So which one's local and which one's absolute? So the lowest point is absolute. This is absolute. This is local, and this is a local max. If you notice, I keep skipping this one, and there's a reason why. Right here, I have an absolute minimum. Absolute minimum. So this is a rational, and there is no maximum or minimum. So be careful and cautious with that. These are not maximums or minimums, and that is all we have for our work regarding extrema. Next video is going to be for transformation.